Okay, Assalamualaikum and good day. Okay, so last class we learned about a AC series circuit. So for today we learn about a more complex circuit, which is parallel circuit, or for this case is actually series parallel circuit. Okay, there are series component for the branch with the I2. Okay, so how to do this? Okay, the same step. So you have to construct a frequency domain equivalent circuit first. So change the current source. Okay, make sure the capital letter I, okay, IS is equal to 8 divided by square root 2. Don't forget square root 2. And the angle is 0. Okay. So how about the inductor? Okay, for resistor, you just keep it. For inductor, you have to change. Okay. So for ZL is equals to JWL. So J is J, okay. W is taken from here, okay. Okay, W is 2,000, 200,000, and L is 40 micro. 40 multiplied by 10, negative 6. So the answer is, using your calculator, is the answer is J at 8 ohm. Don't forget the unit is ohm. Okay, then you calculate this, the capacitor. So capacitor is Zc is equals to negative J divided by Wc. So Wc is negative J divided by 2,000, so 100,000 multiplied by 1, 10, negative 6. So what is the answer? Zc is, so the answer is negative J5 ohm. So you have changed everything, and the lastly you have to construct the frequency domain circuit. Okay, you have to construct it back because they will be marked. Okay, if you don't do this, it's usually you lose around 1/3 of the mark. So resistor, inductor, and lastly capacitor. So don't forget to write everything back. So 8 divided by square root 2 is, don't just leave it like that, you have to solve this. So 5.665 angle 0 ampere. Okay, you can use A or ARMS. Either way, it automatically assume as RMS. So 5.66 angle 0, this one is 10, this one is 6, this one is J8, and this one is negative J5. Okay, so you already answer the A question A. Okay, next, find I1, I2, I3. So how to do this? So you can use the, okay, let me copy this first. Copy. Okay, so question B. So find I1, I2, I3. So you can use a current division rule. So I1 equals to, okay, remember, assume this is Z1, this is Z2, this is Z3. So for Z2 is basically just plus this because this is in series 6 plus J5. Okay, from, oh sorry, J8 ohm. So you just add together because it is just in series. So to get I1 is just 1 over Z1 divided by 1 over Z1 plus 1 over Z2 plus 1 over Z3, then multiply by the current source, okay, which is 5.66 angle 0. Okay, so how to solve this I1? Then just take the value, okay, so 1 over 1 divided by 1 over 10. 1 over 10 divided by 1 over 10 plus 1 over 6 plus 8 J, 6 plus J8, and plus 1 over negative J5. Negative J5. Okay, and then multiply by 5.66. So this is how to solve this if you use Ohm's law. Okay, sorry, use current division, current divider, the current divider RULE. Okay, so how to enter this into your calculator? So if you use this calculator, don't forget to shift clear all first. Okay, then mode complex. Okay, then enter into calculator 10. Okay, divide by, don't forget open bracket, 10. Okay, reciprocal. Okay, this is the reciprocal plus, okay, open bracket again, 6 plus 8J. Okay, or close bracket, and then close bracket, then reciprocal. Okay, don't forget the bracket, and then lastly minus, or you can use also okay, plus open bracket, okay, negative 5J, close bracket. So be careful if it is negative. Okay, sometimes they will become a problem, so don't forget the close bracket again, and then lastly multiply by 5.66 angle 0 shift angle, and then 0. So it is equals to this. Okay, so okay, make sure, okay, after you enter this, you have to make sure that you enter it correctly. Okay, for this case, okay, forget reciprocal, then I go shift delete, means that insert negative 1. Okay, so equals to, okay, this, can shift equals to this. But remember, this is current, so you have to use the polar form. You cannot use rectangular form. Shift plus equals to, you get 2.83, then shift equals negative 36. So again, shift equals, okay, 2.83, 0 equals to 2.83. The angle is negative 36.85. 7 ampere. Okay. Okay, this is for the old calculator. If you use the new calculator, okay, if you use the new calculator here, okay, first you have to shift and number 9, which is reset, then press 3, okay, equals to again. So you clear everything first, then shift goes to number 2, okay, equals to mode, enter complex mode, then use the same way, then okay, reciprocal, okay, this is the reciprocal, divide by, okay, open bracket, then reciprocal, okay, plus open bracket again, 6 plus 8i, okay, don't forget reciprocal, okay, and then plus, okay, open bracket, negative 5j, okay, close reciprocal, and then close bracket. Okay, this one already divided. Okay, so don't forget to multiply. Oh. So multiply by 5.66. Okay, angle shift 0. Okay, equals to, okay, you get this, and make sure you change this to rectangle polar form. Okay, press option and then goes down, and number 1 equals to, you get the answer. And make sure you use this form, okay, decimal point. So press DSD, okay, you get the decimal point, you get the same answer. Okay, that is for I1. How about I2? Okay, how about I2? Okay, for I2, okay, so for I2 equals to 1 over Z2 divided by 1 over Z1 plus 1 over Z2 plus 1 over Z3 multiplied by 5.66. So 1 over, okay, 6 plus J8, okay, divided by 1 over 10 plus 1 over 6 plus J8 plus 1 over negative J5. So multiply by 5.66. So that is how you get this. And don't forget, when you enter into your calculator, make sure you close the bracket 6 plus J8. Okay, you have to make sure this. Okay, this is if you're using current division rule. But if you use Ohm's law, it's much more easy actually. So here I give you example to get the Ohm's law. Okay, so how if you want to use Ohm's law? Okay, so first you have to find Z equivalent. So what is Z equivalent? So this is a parallel, so just 1 over 10 plus 1 over 6 plus J8 plus 1 over negative J5, and don't forget to reciprocal everything. So enter into your calculator. Okay, so you get the answer is 4, okay, minus 3J, okay, J3 ohms. Okay, So this is in impedance. So make sure that you use rectangular form. So after you get the Z equivalent, okay, ZEQ, this one is IS. So you get the voltage. So V equals to ZEQIS equals to 5.66 angle 0 multiplied by 4 minus 3J. Okay, so the answer is 28.3, and the angle is negative 36.87. okay, volt. So then you get the volt. So is this much more? Make sure the form is in rectangular form. And then lastly, if you want to get I1, just V divided by Z1. So V is 28.3 angle negative 36.87 divided by 10. Okay, Z1 is 10. So the answer is, okay, for this case you just move this, okay, 28.3 divided by 10. So you get 2.83 angle negative 36.87 ampere. Okay, this is for I1, and then for I2, V divided by Z2, okay, you get 28.3 angle negative 36.87 divided by 6 plus J8. So use your calculator. So when you use your calculator, don't forget to bracket this, okay, and don't forget the negative, okay. Then after your calculation, you get, make sure it is in polar form. So 2.832, okay. So okay, 2.8, okay. The angle is negative 90 ampere, okay. So you get I2. So this method is much more faster. So depending of the question, okay, some are, if you use complex number, if you use current division, it is much more faster, but sometimes using Ohm's law is much more faster. So if the question doesn't specify, I suggest you use Ohm's law. So I3 equals to V divided by Z3. So 28.3, okay, angle negative 36.87 divided by negative J5. So what is the answer? So 5.66 angle, don't forget the angle, use polar form, 53.13 ampere. Okay, don't forget the angle. Okay, this one angle and this one angle. Okay, don't forget the angle. So you get I1, I2, and I3. That is how you solve the AC circuit, okay, for parallel AC circuit. Okay, this is all for today. Okay, have a nice day, and thank you.